Hello and welcome. So we're going to identify and graph information for a hyperbola. So first off, let's look at our equation. First thing we need to know is the orientation. Are we vertical or horizontal for this hyperbola? And how we can tell is we look at our first term, right? That is the term with x, and it's positive. So if x is positive, you're going in the x direction, meaning it's a horizontal hyperbola. If this was instead where we had the y plus 4, right, if that term was positive and we instead had that with a subtraction in front, then it would be a vertical hyperbola, right? So x is positive, horizontal. Y is positive, vertical. Okay? So we know right now, bam, we have something looking like that. Okay? So first off, let's find the center. Center is h comma k of your hyperbola. Now the general equation for a horizontal hyperbola is as follows. That'd be x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay, so if we're looking for h and k, that's just the numbers being subtracted or added to your x and y values. So notice it is minus h and minus k though, meaning that you are using the opposite sign of what you see. So if we have plus 1, you'll be using minus 1. If you have plus 4, then it will be minus 4 inside the center. There you go. Alright, now your vertices, because it is a horizontal hyperbola, is going to be, here's your center, right? It's going to be your a distance to your vertices, right? Vertices are the turning point of each curve. And because it's horizontal, that means you're going to have your h value plus or minus a, and your y value, the k, is going to stay the same. Right? Now your covertices, however, are going to be that distance up, right? That'll be your b distance, which it's not asking for covertices for that one, so we'll just kind of hold off there. But that will be for your vertices. So let's find that. So our a squared, right? A squared is what we see under our x, and that number we see there is 4. So our a squared equals 4. Take the square root, our a is 2. Right? You don't need the plus or minus because you already have the plus or minus a there. So that means that we have essentially negative 1 plus or minus 2, comma, negative 4. So negative 1 plus 2, 1, comma, negative 4. And then we have negative 1 minus 2, negative 3, comma, negative 4. And those are the vertices for your hyperbola. So essentially what we have, let me graph some of these down. So we have negative 1, negative 4 as a vertice. Wait for it. Sorry, negative 1, negative 4 is the center. I do not know why I just struggled on that one. And then we have negative 4 as our vertice, and then we have negative 3, negative 4 as our other vertice. Okay? And we know the hyperbola is doing something like that, right? Okay, so now we have our foci, right? Both for focus points, and we find that from the Pythagorean relationship. So for a hyperbola, that is a squared plus b squared equals c squared. And we already know our a squared and b squared, right? Those are just the numbers beneath in our denominators of the fraction. So we have 4 and 25. So we have 4 plus 25 equals c squared. What's 4 plus 25? 29. So that means your c squared equals 29 there. So that means we get c equals the square root of 29. And again, we're about to use plus or minus, so having plus or minus from your square root isn't going to make a big difference there. Okay? And the reason why we need the c value is that your foci are along the same line that we get along our vertices, or our foci will be a little bit further than our two vertice points, right? So it's going to be h plus or minus c, comma k for that one. So we already know our h, right? It's negative 1 plus or minus. We just found c to be the square root of 29. And then comma k is still negative 4. There you have it. Right? So all we do from there is now we just got to write those out as two separate coordinate points. So we have negative 1 plus square root 29, comma negative 4. Right? And then you'll use a comma because it's a list, negative 1 minus square root 29, comma negative 4. And that's all of your information. Then it's just your turn to graph it. Right? Now, in order to graph this, you actually don't need anything too crazy. You'll notice that it's one of these tools right there. Now, we already determined that we have a horizontal hyperbola, right? So you're specifically going to be using this tool right here. Now, you notice your first point is the center, And your next point is actually not either, it's not a vertice or a covertice. It's going to be like an edge of a box that forms from both vertices and covertices. Essentially, all it is your distance A and your distance B for this one. All right. So for this, it would be your distance A, which we said was square. So A squared is 4, so square root of 4 is 2, right? A is 2. So that means we're going over 2, which we already have. That's your vertices. Wink, wink. Okay, and then we have your distance B, which is going to be the square root of 25, which is 5. So you'll be going up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. And the same thing from your other point as well, and it creates this cool box. Okay, now in order to graph this on the computer, the only points that you need to know is you need to know your center and one of the 4 corners of these boxes. Okay, so you got to know either A distance left or right, right? A's distance up, B distance up or down. Okay, and as long as you can find one of the 4 corners of the box, it will graph the hyperbola correctly for you. Okay, now I'm just going to continue graphing this by hand, right? Connect the corners of your box together. That is your vertical oblique asymptote. All right, connect the corners, oblique asymptote. Okay, and then it would be doing something like this. Okay. It's a very, very rough sketch by hand, but more or less, that would be your hyperbola. Alrighty, there you have it. Thank you so much for watching.